Hi Gandhi class, welcome to our fourth maths lesson this week. It was so fantastic seeing you all in our live session earlier, and I got some really great feedback from you about the maths. Now, a lot of you told me that you found activity 3 from Tuesday's lesson a little bit tricky. So I'm going to go through how to answer questions A and B, and hopefully that will help you when answering question C. So let me take you to my book so I can show you how to work it out. Okay, so we've got the question, the fruit shop contains 3 times as many apples as oranges. Altogether, there are 48 pieces of fruit. How many apples are there and how many oranges are there? So what this question is asking us to do is it wants us to work out how many apples we have at this fruit shop and how many oranges we have. But the only other bits of information that we know is that there are 48 pieces of fruit altogether, and you've got 3 times as many apples as there are oranges. So by that sentence, we mean for every 1 orange, I'll put O for orange here, for every 1 orange, you have got 3 apples. Okay, so I'm going to count these up together. 1, 2, 3, 4. I've got 4 blocks that I've drawn. And what I'm going to do next is 48 divided by the 4 here, because that will let me know how many is in one group. So 48 divided by 4 equals 12. So I know each of these is going to be worth 12. So that's 12, that's 12, that's 12, and that's 12. So we know that oranges, we've got 12 oranges. So I can write the answer for oranges here. But I need to find out how many apples there are as well. So to work out how many apples we have, we can either use repeated addition or we can use multiplication. So we know that we've got 3 lots of apples, and in each lot we've got 12. So 3 times 12 equals 36. So we've got 36 apples. Now, one way that we can check to see if we are correct is by doing 36 add 12. So we're adding together how many oranges we have and how many apples we have. And if we do this, we can see that we have got the correct answer because we have got 48 altogether, and we know that there are 48 pieces of fruit. Let's move on to the next question. So the next question says, Mr. Green is 4 times the age of his son. Their combined age is 55. How old is Mr. Green? So we just need to find out how old Mr. Green is. And the only other bits of information that we've been given is that their combined age is 55 and that he's 4 times older than his son. So that means that his son, for every 1 year of his son, Mr. Green has 4. So if we count all the boxes, we've got 1, 2, 3, 4, 5. So what I'm going to do next is divide 55 by 5. 55 divided by 5 equals 11. So then I know that in each of these boxes, it's going to be worth 11. That means his son is 11 years old, but we want to work out how old Mr. Green is. So what we can either do is we can either have a repeated addition number sentence by doing 11 add 11 add 11 add 11, or we could do 11 times 4 because we've got 4 boxes for Mr. Green here. And 11 times 4 is 44. So that means Mr. Green is 44 years old. Now we can check this by adding together the son's age and Mr. Green's age to check to see if their combined age is 55. So if we do 44, add 11, 4 add 1 is 5, 40 add 10 is 50, and the answer is 55. So Mr. Green is 44 years old. I hope that's helped you, Gandhi class, and I hope that you'll be able to answer part C from those questions. If you do, fantastic, please upload it to Tapestry. Okay, let's go back to our lesson for today. So our learning objective for this lesson is, can I calculate the possible combinations resulting from two groups of objects without listing them? So in last lesson, we listed the objects and we're going to try and do it without listing them. So here we have a deck of cards. The Mathstronaut picks out one red card and one black card. And you can see here, we've got 4 red cards and 3 black cards. How many different possibilities are there? And how many combinations contain the black 8 card? Yesterday, we looked at working systematically to work out how many combinations there are. So we're going to do that again today, just as a quick starter, and then we're going to move on to how we can do it without having to share them out and look at all of the combinations. So what I want you to have a go at doing now is pause the video to have a think about how many different possibilities there could be and how many combinations would contain the black 8 card. Pause the video to have a go. Okay, so let's start with our 8 card. So we've got 8, and then I'm going to put him with the 4. Another 8, put him with the 5. Another 8, put him with the 6. And our final 8 to put him with the 7. Then let's move on to the 7s. So 7, I'm going to match it with the 4. Then another 7 and match it with the 5. Another 7, match it with the 6. And our final 7 to match it with the 7. And then I'm going to move on to the 6. So 6 and match it with the 4. A 6 and match it with the 6. Another 6 and match it with, 6 should be there and the 5 should be there. And the last 6 and match it with the 7. So we have systematically looked at how many combinations we could have. So let's now answer our questions. How many different possibilities are there? Pause the screen to have a look and see how many there are. Okay, so we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 possibilities. And now we need to have a look at how many combinations contain the black 8 card. So pause the video and find all of the combinations that contain the black 8 card. Pause the video. So we're only looking for the ones that contain the black 8. We've got a black 8 here, the black 8 here, a black 8 here, and a black 8 here, which means we've got 1, 2, 3, 4 combinations there. Well done if you got those answers. The Mathstronaut picks one red card and one black card. But was there a quicker way of doing this rather than having to place the cards next to each other? So can we find the total number of combinations without listing them? Pause the video and have a think if you can think of a way of finding the number of combinations, but without having to list them. Okay, so what we could do is look at how many is within each group and multiply them together. So if we have a look at the black group here, we've got 1, 2, 3 cards. So it's going to be 3 times something. And then if we have a look at how many red cards we have, 1, 2, 3, 4, we would times it by 4. And 3 times 4 is 12, which tells us the amount of combinations we could have without having to list them out like we did here. Well done if you realised that we could multiply them together. Okay, let's have a go at doing that again, but with this question. So Eva chooses a snack and a drink. What could she have chosen? How many different possibilities could there be? So look at how many drinks we have and look at how many snacks we have. Pause the video to work out the amount of possibilities that we could have. Okay, so we've got 1, 2, 3 drinks. So it's going to be 3 times something. And we've got 1, 2, 3, 4, 5 sweets. And we know that 3 times 5 is 15, which means there are 15 possibilities of combinations that she could have had. So our next question. The astronaut tries on some different spacesuits and some different helmets. He can make 18 different outfits. How many of each item might he have? Now, you could either try to use your knowledge of the times tables to write out the different combinations. So you do number of spacesuits times number of helmets equals 18, or number of helmets times number of spacesuits equals 18. So for example, you could have 1 times 18 equals 18, which means one spacesuit and 18 helmets, or 18 times 1 equals 18. So 18 spacesuits and 1 helmet. Pause the video to have a go at doing this question. Okay, so we could have, as we said, 1 spacesuit and 18 helmets. We could have also had 3 spacesuits and 6 helmets, or 6 spacesuits and 3 helmets. Or we could have had 2 spacesuits and 9 helmets, or 9 spacesuits and 2 helmets. Those are some possibilities that we could have had. Now it's your turn. I want you to start with activity 1 and have a go at activity 2 if you want to challenge yourself. So, activity number 1. Trisha chooses a colouring pencil from the following colours: red, blue, pink, yellow, and green. She then chooses a piece of paper from the following colours: white, purple, and brown. How many different combinations could she make? So remember, you need to times how many is in this group by how many is in this group to find out the amount of combinations. B, Rajan can choose between these meals at school: beef, lasagna, veggie lasagna, pasta veg, or a jacket potato. He can then choose one of these desserts: yogurt, cake, or fruit. How many different combinations could he have? Remember, you need to look at how many is within the first group and times it by how many was within the second group. Activity number 2, challenge. So we've got a worded problem here. Part A says the cafe sells some different sandwiches and some different drinks. It advertises that altogether there are 24 possible combinations to be made. How many different sandwiches might it sell and how many different drinks? Part B says the clothes shop sells different coloured hats and some different coloured scarves. Altogether there are 20 possible combinations. How many different colour hats might there be and how many different colour scarves? Please make sure you upload all of your work to Tapestry Gandhi class, and I will see you next time. Bye.